Hello, this is Mr. Waters, and here we are again with the second in a series of videos about sequences and series. And this is again about the work on page 789. And this will be, hopefully, a short little video about this symbol here. That guy right there. Okay, that indicates something called that's an indicator of something called a series. Okay. Now what that really is that's the Greek letter sigma, the uppercase Greek letter sigma, and it's the equivalent of the English letter S. And S is for summation. Okay? So whenever you see that symbol, that big, it looks like an E, but it's supposed to be kind of an S, it indicates a summation, that you're adding a list of things together. Now in the case of a series, what that means is you're adding the terms of a sequence together. And when you add the terms of a sequence together, you get a series. So this is a sequence. 1, 3, 5, 7, and so on. Okay? And actually, let's go ahead and say that we've just got, let's stick with 4 terms in the series. So we're going to say A sub n is equal to that series, 1, 3, 5, 7. Now, the sequence. So this, don't want to get my terms mixed up here. That is a sequence, such as we've been working with. The corresponding series would be the sum of those 4 terms. 1 plus 3 plus 5 plus 7. That is a series. So if you take the terms of a sequence and add them together, that's the series. So we'll write that down right here. Roughly speaking, a series is the terms of a sequence, however many you want, added together. See, D there. Added together. Now, of course, a series has a sum. 1 plus 3 plus 5 plus 7, that adds up to something. Okay, 1 and 3 is 4, plus 5 is 9, plus 7 is 16. So the sum of this series equals 16. So you can have a sequence, which is a list of numbers that follow a pattern, a kind of function. You can take those sequence terms and add them together and write them as a sum, and we call that a series. You can actually add all those numbers together, all those terms of the series, and get one single value, and we call that the sum of the series. Okay? Now, just like with sequences, there's 2 different ways to write it out. You can write the series out as a list, or you can write the series in the form of a formula. Now let's try that out here. So for example, let's say we've got this series here. 2, 4, 8, 16, 32. Okay? Now that is a sequence. If we write it like this, 2 plus 4 plus 8 plus 16 plus 32, we get a series. Now, the sequences and the sequence and the series, of course, have the same pattern. But if we write them as a sum, that works out to be a series. Now, of course, if we add those 5 numbers together, 2 plus 4 plus 8 plus 16 plus 32, I'm doing this on my calculator, we get one specific number, we get 62, and that is called the sum of the series. Okay? Now, another vocabulary thing here that we want to make sure we've got is that when we write the series like this, where we write each of the terms written out with the addition symbols in between them, that is called expanded form. So in your homework, when they ask you for a series written in expanded form, this is what they mean. Written out like that, each member of the series written with plus signs between them. Okay, if they ask you for the sum of the series, what they want you to do then is take those numbers, however many there are, and add them together and get one single value. Okay? So anyway, so that's what we mean by a series. Now, series, just as sequences can be written with a formula, series can be written with a formula as well. So, for example, let me see. So let's pick a series here, or let's pick a sequence: 1/2, 1/3, 1/4, 1/5. There's a perfectly good sequence. So there's a sequence. So the corresponding series in expanded form would look like this. Now, of course, those all add up to something, and we could use, since there's only 5 of them, it wouldn't be too much work to go ahead and actually calculate what the sum of that series is. Okay, so that's what we mean. So this is the expanded form of a series. Now, we could also write, just like we used a formula to write a sequence in shorthand, indicating the entire sequence with a single formula, we can indicate an entire series with a single formula and making use of the sigma sign. Okay, so for example, let's say we have this series, a formula. A sub n is equal to negative 2n minus 3. Let's say that is the formula for our sequence. Now we can generate the first 5 terms of the series simply by let's say the first 3 terms in a series to make this a little bit quicker. I'll put it over here. Okay, the first 3 terms in the series, n is 1, so that would be negative 2 times 1 minus 3. That would be negative 2, that's negative 5, right? And then this is 2, negative 2 times 2 minus 3. That, of course, is negative 7. And then the third term, negative 2 times 3 minus 3, that's going to be negative 9. So the first 3 terms in our series, or rather in our sequence, would be negative 5, negative 7, negative 9. Okay? Now, written as a series, that would be negative 5 plus negative 7 plus negative 9. Now, in sigma notation, that is means writing this as a formula. In sigma notation, we would write this series like this. We write the sigma notation, and that means we're taking the members of a sequence, this sequence, and we're adding them together like that. And we're going to indicate the entire sequence by putting negative 2 and minus 3. So in sigma notation, what I did was I used sigma here to show that we're adding, and then I put in the formula for the sequence, a sub n, which we were given. Now, in this case, notice that we're adding the first 3 terms in the series. So to indicate that we're adding the first 3 terms in a series, I write that as part of the sigma. N equals 1 up to 3. So this means, let's be careful and make sure we understand this. This sigma notation here means we're going to generate the terms of the series by using a formula. And how many terms in a series should we add up? That's given by the numbers above and below the sigma sign. This shows what the first term is that we're adding. Usually it'll be 1. This shows how many terms we're going to add up. So the 3 means we're going to add up the first, the second, and the third term, which is what we did over here. So, vocabulary. Okay, this is for a series expanded form. This is for a series. This is a series written using sigma notation. Okay, so I'm looking at your book here, and I'm seeing that they're going to have you do this 2 different ways. They're going to give you the formula. They're going to give you the series in sigma notation, and they're going to want you to write it in expanded form. Or they'll give you the formula, the series in expanded form, and they'll want you to write it using sigma notation. Now, what that means is, okay, if you're given in sigma notation, you'll start with this, and you'll write it like that. Okay. Or if you're given expanded form, they'll give you the sequence in or the series in expanded form, and they'll have you write it like that. Okay, so they're sort of related problems, as you can see. So here's an example. We're given this sequence here, or this series, I mean, in sigma notation. K equal to 1 up to n, it says. And this is 2k plus 1. Okay, and then what you're supposed to do is, this is the sigma notation. And we're supposed to take that guy and expand it out and put it in expanded form. Now, what does that mean? It means that we want to write out like this. We're given the formula here. We're supposed to generate what the terms of the sequence there are, starting with the first term. Now, up on the top, they just have n. So they don't give us a particular number to generate. So we're going to go ahead and generate, say, the first 3 so we can see what the pattern is. This formula here, we use to tell us what we use to calculate what the actual terms in the series are. The counter is k, and k here is the same as n up here. It's just the counter. It gives you what the term number of what the position of the term is. So we would go ahead, the first term, I'm going to make a t-table here, just like that, and we're going to go ahead and generate, say, the first 3 to get an idea of what this is. So here's k. K is 1, so this is 2k plus 1. Okay, so 2 times 1 plus 1, that's equal to 3. Second term, 2 times 2 plus 1, that's 5. Third term, 2 times 3 plus 1, that's 7. So here is how we will write it out. 3 plus 5 plus 7 plus. Now, if they had given us a particular number to stop at, like 7, we would keep calculating out until we'd gotten to 7 here. But they don't give us a particular one to stop at. That's what n means. So we're going to write plus dot 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 to show that it keeps going to however we don't know when, plus, and the last term is going to be something equal to 2n plus 1. So this is our series written out in general form, or an expanded form, where that's the first term, and this is the nth term, is any term that we want. Okay? Okay, so let's try another one here. Let's try, say, here's a formula I'm looking at. sigma 1 to n 2 to the I don't know, wait, no, let's do something a little bit different here. 1 over 2 to the k minus 1, say. Okay, so we're going to make, what we want to do is kind of as a representative, we'll calculate out what the first three terms of the series of the sequence are. So we're going to change this to expanded form. Okay, so this is going to be okay, and this is going to be 1 over 2 to the k minus 1. So 1. So this is going to be 1 over 2 to the 1 minus 1. That's 2 to the 0, which is 1, so that's equal to 1. The second term in the series is 1 over 2 to the 2 minus 1, so that, of course, is 1/2. And then the third term is 1 over 2 to the 3 minus 1, which, of course, works out to be 1/4. So we're in expanded form. We're going to write our sequence like this. Well, we're going to write our series like this. 1 plus 1/2 plus 1/4 plus dot 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 plus 1 over 2 to the n minus 1, showing that our series starts at 1 and then goes up to 1 over 2 to the n minus 1, n being whatever we want. So if we wanted the first 7 terms, I would substitute 7 in there. If we wanted the first 9 terms, I'd substitute 9 in there. And that would give us out to 9 terms. Anyway, so I think this is enough for now. I'm going to make another video with how we go the other way, how we, given the expanded form, how we calculate how we put the series in sigma notation, which is slightly trickier. Anyway, thanks for listening. Thanks.